Hello everyone and welcome back to Science Live. We're here coming to you from the Creation Museum again. It's a beautiful sunny day outside. I'm thinking about maybe some fly fishing or something this afternoon.
Oh, I saw a lot of people doing that yesterday actually.
to get out and enjoy nature a little
Yes.
bit. Here again with Dr. Rivera, and she's joining me to help us monitor comments and things. We'll give a few minutes here as people are jumping on and getting notifications, and we'll be looking at your comments again today. So if you've got any questions or things, we'll try to get to some of those during the broadcast, and then I'll be hitting the page afterward and answering as many questions. It's been great to be able to interact with some of the kids and seeing who they are and where they're from, and trying to answer those questions. You guys are very inquisitive, and I think that's the key to learning. We are our goal is to try and show you how God has made the world in an amazing, wonderful way, how we can understand those things through science, and then take advantage of those to help us do lots of things in the world around us. All right, today our topic is combustion. So if you looked at the description,
That sounds exciting.
there were some fire emojis and some explosion emojis. So we're gonna have some fun today, and everything is going to be done right here at this counter, and then we're going to transition outside. There might be a really big explosion at the end if you stay tuned. So today we're going to be working with fire. So you might think, all right, we're working with fire. Why don't they have their safety glasses on? So let's go ahead and do that right now. We're going to do that.
Safety first.
And when we're working with fire, there's some other precautions we want to take.
I'm wondering, since you said fire, if we're going to need this today.
Probably not, but let's just have it handy just for
Okay,
safety.
I'll keep it close by.
Okay.
Because you never know.
All right, so when we're talking about the word combustion, that's the scientific word we use to talk about when things are burning. Typically, we think about hydrocarbons as a fuel source. So a fuel is something that when it's in the presence of enough energy, like heat or a flame or a spark, it will spontaneously combine with the oxygen around it to create an exothermic reaction. So exo means lots of energy is going out, thermo energy, so it's exothermic. And that's why we get explosions and we get heat off of flames and things. So the key ingredients we need to have a fire or combustion is a fuel source, typically a hydrocarbon, and oxygen, and some type of ignition source. So those are the three things we need to get the reaction going. And then, since it's a chemical reaction, whatever we put in on one side of the reaction, we have to get out on the other side of the reaction. That's part of the law of conservation of energy and matter. So we're going to look at some of those reactions and how those things interact. We're going to start out today with a little flame here in this dish. I've got a bottle of ethanol. So this is, another word for this would be ethyl alcohol. And this is a hydrocarbon source. And we're going to put a little bit of this ethanol here, just a tiny little bit, in this watch glass right there. Set this aside where it's back out of the way, away from the flames. And we're going to light this ethanol on fire, and then we're going to look at what happens to it. So what we're going to do is we're going to watch the flame burn, and then I'm going to put this beaker over the top of it. Right, so I want you to predict what you think is going to happen. We're going to go ahead and dim the lights so we can see the flame a little better. All right, we're going to light this on fire. Maybe, there we go. You can see that nice blue flame. So when I come in here and I put this beaker over the top of it, eventually it burns out a little bit. And that is an example of how we ran out of one of our parts that we needed for the reaction. We ran out of the key ingredient of oxygen because there is still alcohol left on the dish there. You can still see that's present. So we still have alcohol, the fuel is still there, but we ran out of oxygen. And then if you can get in there with the camera a little bit, we can see that there is steam on the inside of the beaker. So that tells me that one of the products of this reaction is water. So when we burn stuff, two of the key ingredients that we get are water vapor and the heat comes off of it. Those are the things that are released in the reaction. We also get things like carbon dioxide, carbon monoxide, and sometimes just carbon. So we're going to look at how we can use that combustion reaction to make things happen in the world around us. Any questions coming in?
We did
yet?
have a question about spontaneous combustion.
Spontaneous
Yes.
combustion. Spontaneous combustion is great fun in the movies and in
Yes.
science fiction, but it's not something that happens. There's always some type of explanation for those types of things. You may have heard of somebody's compost pile spontaneously combusting. That's not really spontaneous. It's the heat generated by all of the microbes, the bacteria and fungi that are creating heat as they digest all of that food that is producing that heat. Now, there are times we can think about in the Bible. I can think of a spontaneous combustion event in the Bible where Elijah was meeting the prophets of Baal on the mountain. That sacrifice that he offered to God spontaneously combusted. Hey, that was a miracle. But for the most part, we have scientific explanations for the things that are happening around us.
We did have a funny comment. Someone wants to know if our cameraman has safety glasses on.
He does not, but he's far enough away that we're not concerned about that. Definitely want to be safe. Okay, so in this can, I have a substance called calcium carbide. It's actually a rock you can get out of the ground, and I'm going to use my tweezers to grab a chunk of that out of here.
I don't think I have ever seen
those are some honking tweezers, aren't they?
That big. Those are impressive.
All right, so this little rock here, this chunk of calcium carbide, is going to be a source we're going to use to generate a fuel. So calcium carbide has traditionally been used by miners. They would put it in a container inside of their lamps, and it generates, in the presence of water, it generates acetylene gas. So you may be familiar with acetylene. It's what welders would use in their gas tanks to weld metals and use for cutting torches. So it's a hydrocarbon source that burns at a very high temperature, has the formula C3H8. So you can see the carbons and the hydrogens. So it's a hydrocarbon source. We're going to put it into this little dish and add a bit of water for it to react with. So when calcium carbide is in the presence of water, it liberates little gas bubbles of acetylene. And to help kind of capture those, we're going to add a little dish soap, increase the surface tension of the water there, and a little more. A little more won't hurt. Give that a quick stir. I'm going to drop this in here, and you'll see an immediate reaction of these bubbles forming. And if we can get one of them to come up here, form a nice big bubble. I scared the cameraman. We get little poops of flame coming out of there. So each of those bubbles is releasing acetylene gas, and we can ignite that on fire. So here we've generated a hydrocarbon fuel source by using the calcium carbide. And we can do that in an even funner way and demonstrate this idea of oxygen and the amount of oxygen we need for combustion in these test tubes. While I'm getting this going, any other questions coming
There
in?
was a question about the ethanol experiment.
Okay.
Someone said, what in the ethanol makes it burn? Like what property?
Just the fact that it's a hydrocarbon, and one of the natural properties of hydrocarbons is that they tend to interact with oxygen. It's a property of what we call electronegativity. Different atoms tend to give away or hold on to their electrons more closely or tightly. So the carbon is in the hydrocarbon is more likely to lose its electrons to the oxygen. So the oxygen is basically stealing the electrons away from the carbon in the hydrocarbon and pulling them to itself. That's what makes chemical reactions go, and that's why atoms switch places. Okay, so what we're going to do here, I'm going to drop a rock of the calcium carbide in here. We're going to fill one of these test tubes full with acetylene gas, 1/3, 1/2, 1/4, and one just a little bit. Little bit's the scientific term for a little bit. Okay. So we're going to add one of these rocks, and we're going to look at how the amount of oxygen affects the burn and what the burn looks like. So I'm going to drop this in here. I've filled these test tubes up with water, and as I hold this over the rock, it's going to bubble into the test tube and force the water out. And that one's full. That's our clear full. This one we're going to fill about 3/4 full. Let that water drain out. Now as I put that on the counter, the water around the rim of the test tube will seal the gas in there. This one we're going to do about half full. This one we're going to do about a quarter full, and we're going to try and grab a couple of them with just a little bit. All right, that rock's slowing down. It's not going quite as fast now. Okay, as I pull the tube out and let the water drain out, what's filling up the tube as the water drains out? And the answer is the air in the room. And what does the air in the room contain? It contains oxygen, one of those elements that we need for a fire to be able to burn. Okay, so we're going to compare how different amounts of oxygen affect the type of combustion that we have going on. We'll set this over to the side so it's out of our way. Okay, in this first test tube, we have this full of acetylene gas, and let's watch what happens when we ignite this test tube. Notice the flame is only burning, and this is a dense gas, so I'm letting it flow down the tube. The flame only burns right at the mouth of the test tube. Oh, there's a little more gas in there. We'll go ahead and blow that one out. 3/4 full. It burned into the tube just a little bit and left a lot of black soot in there. Half full. Burns down into the tube and gave us a lot of black sooty material there. 1/4 full. Burned down into the tube a bit more quickly, and we've got all these little black particles floating around in the air. We'll show you those in just a second. Okay, this is the fun one. Get ready. Oh, okay. Notice in this tube, we have virtually no black material in it, and it went very quickly. Now, what do you think all the kids at home are saying right now? I think they're saying, do it again. Okay, so let's try this one more time. And we get that nice little flame shooting down inside. Okay, we go ahead and turn the lights back on now. Okay, so what happened here was with the tube that was clear full, there was no oxygen inside the tube. So the flame couldn't burn in the tube, it could only burn out here where there was a source of oxygen. And one of the byproducts are these little particles of black soot that are floating around in the room. Okay? That's why we wear lab coats, to keep our clothes clean. This one burned a little bit into the tube, but it didn't have as much oxygen. This one burned more into the tube, a little more into the tube, a little faster. And the ones that were full of oxygen, or full of the air contains about 20% oxygen, they burned very quickly and cleanly. So if you were trying to design an engine to burn these fuels to do some type of work or to heat your house, which one would you want to use? Would you want to use this one that creates all the black sooty material? No, that's going to be problematic. So learning about the different oxygen mixture and how the fuel to air ratio in a carburetor or a fuel injection system works is very important for understanding making efficient engines. That helps us do good energy conversion, so we're saving money and not wasting those resources, being good stewards of God's creation, and reduces pollution and things. So these are things that we can do and study and understand to help conserve God's world around us. Any other questions coming in?
There was a question about what other gases are flammable.
Other gases that we use as flammable substances would be anything like propane. Okay? Propane is a common one we use in your barbecue grill or lanterns if you're camping and those types of things. Butane is another one that can be used. That one's kind of a liquid gas. You can get little cylinders of butane to fill lighters and those types of things. There are lots of other alcohols that will burn that can be used as fuel. You might think of the sterno little pellets that you can get, those types of things. But all of them are hydrocarbons, and that hydrocarbon is what makes it burn.
We did have one person ask, why does the flame make it pop?
Oh, okay, the whistle sound that you heard, which is the cool part and usually scares people. This is my favorite part of this experiment when I do it with students, is there's always a girl in the room who will scream whenever this happens. So the whistle comes from the burn is happening so quickly that it's actually heating up the tube and forcing air out, and it's making the air move inside and outside the tube, just like you do if you blew across the top to whistle. So it's just doing that very quickly and making that whistle sound. So all of those things are a product of the speed of the reaction, and that's happening there in the test tube. Okay, that's the basics of what we're talking about today. We've got something super fun planned in just a minute, so hang on. But we want to remind you guys, we've got our promotions going on, our 20% off discount on the web store with Matthew 6 as the promo code. And we have for you today The Riot and the Dance. This is an amazing documentary. If you love watching nature shows and you're sick of all the evolutionary garbage that's in them, then The Riot and the Dance is a God-honoring alternative for your family to watch. They've just come out with a new version of Water, and they'll be, it was released in theaters recently, but that'll be available on DVD soon. This afternoon, continuing with the Facebook Live programs, Dr. Rivera will be doing kind of a Q&A about one of her science, talking about how her understanding of forensic science, being trained as a forensic scientist, impacts her view of the world and those things. And then we have reptiles this afternoon with Karina and Ken. We'll meet some fun reptiles, snakes and turtles and tortoises. And then tonight, looks like they'll be down at Beans, one of my favorite restaurants.
Shops, yeah.
Fish shop.
Pastries.
Good pastries. The maple bacon donut is amazing. Always got to stop there on my way down, but my gallbladder is acting up right now, so I got to be careful.
To avoid that.
No maple bacon donuts right now.
Yes.
Okay, make sure you check out those. All right, we're about to make a little transition over here, so Dr. Rivera is going to grab the mic. The exciting fun thing we've got for you today is we're going to be using a potato cannon, okay? So this is another example of combustion. We're going to be using as our hydrocarbon source today something that you're maybe familiar with, hairspray. Okay? I've tested lots of different materials over the years. Hairspray has always been the best one for me. And we're going to be using this tube as our combustion chamber. So the combustion is going to be happening in here. And we're going to make some pressure inside of this container by screwing on this lid onto here. And then we're going to fire this wet rag. Now it's a wet rag because we don't want it to be catching on fire. So wet rag we're going to cram down in here just to show you visually how that works. But this is a potato cannon for a reason, because we're going to be firing a potato in just a minute. But I forgot to bring a potato from home. What are we going to do? The potato clock. Oh, if you were here for the other one.
Yesterday.
We're going to grab a potato out of the potato clock. There's our potato. Okay. I will slip that in my pocket. All right, we're going to try and make a quick transition outside here. In fact, you know what? I'm going to stuff this rag, get it started before we head out there. And we're going to transition outside. There's some lawnmower and other fun things going on out there, so head out there as quickly as we can here. Okay, so I've got my wet rag in there. I'm going to use this as a ramrod. Oh no, we forced it all the way through. Too much pressure. Oh, then I dropped the hairspray. Okay, I need more pockets. Alright, so we're going to put this back down in here. This will be worth the wait, I promise. Oh, I got two more. Not enough. Not too much.
Coming out first.
Okay, this first one. Down there. Okay, this first one we're just going to do as a simple demonstration of what the cannon looks like when it fires. So So in here I have a little piezoelectric striker like you see on a barbecue grill. And it'll create a little spark inside of our chamber. All right, you can go ahead and step back over here, Dr. Rivera. Have our rag in there. Countdown with me. 3, 2, 1, fire. Ah! Failure. We're good. All right, a little more fuel. 3, 2, 1, fire. Oh. I wonder if we're not getting enough pressure with the rag. Tell you what, we're going to skip this and go straight to the potato. Of course, everything worked fine last night as I was testing everything.
But that's science.
That's the curse of the scientist.
It is.
There's my red dot. Okay. Set that aside.
We do have a question. Is there any other chemicals in there they're asking?
This is the propellant in here. There's probably a little bit of alcohol, and whatever they're using is the propellant in the hairspray is what's going to do that. Okay, so we're going to put this potato on here, and the goal is to get a good seal. I've got a nice seal around there. Get it down there. Now, okay, the trick is for me to get this on here as quick as I can after I spray it. So let's try and do this. Okay, this is a little inexact because I'm trying to get the right amount of air and fuel mixed together out of a spray bottle. So let's see if this one works. All right,
Okay.
What am I going to shoot? Oh, look, there's a sea monster across the lake. Let's see if it will work for us. Oh! Skipped right through it. Okay, so you heard that loud explosion, and that explosion was the combustion happening inside of that tight chamber and releasing all that pressure. You that potato shoot clear across the pond, skipped right between.
Almost got him.
That was a pretty good shot for my first try. All right, so lots of ways that God's created the world. We can enjoy it and just see how He's created these hydrocarbons for us to use in things like combustion engines and heating our homes, all kinds of fun things. We are done for the day, and we will see you back again for more fun chemistry stuff, and God bless.